And you've made it to the last session. So in this session we'll talk about the smoothing and statistics tabs, and then we'll wrap up and review our original objectives. Hopefully we have accomplished them. And so let's jump in. Smoothing tab, before we jump into it, you can see it only has a few operators: center moving average, Olympic smoothing average, and forward moving average. But let's talk about what smoothing is and why you'd use it first. This is probably old news to many of you, but maybe not to everyone, so let's do this. The reason you would want to smooth your data is because it is too jittery. It bounces around too much. And the reason you would smooth it when it's jittery like that is because we don't believe that bouncing around represents truth or represents reality very well. And we believe that a smoother time series represents reality better. An example of when this can happen, that's not the only example, but is a good example, is if you have a time series of elevation data for a reservoir. Now, depending on what the reservoir is, what its storage is, what its surface area is, the way it's oriented in the wind, and what the proclivities of the wind are, in that particular area. The elevation can be greatly affected by wind and wave action, and doesn't reflect, or the elevation measurement, I should say, can be greatly affected by wind and wave action, and doesn't truly represent a good analysis of the elevation. What is even worse is if then you have a elevation capacity curve, an elevation storage curve, a rating, and you use the elevation data rated into storage in combination with discharge information from the reservoir to compute net inflow. The jitteriness in the elevation data gets magnified through the elevation capacity curve, and your net inflows can look ridiculous. And so we tend to say, let's smooth these. Now, those aren't the only occasions where you'd ever need to smooth anything, but those are very typical applications of smoothing. Now, so that's why would you use smoothing, but what is it really? So smoothing is replacing a value with an average of the values around it. And depending on how we smooth, we'll talk about the different methodologies of smoothing here in a minute, but that's really what each of them does. It says, okay, in order to make this better reflect reality, we're going to take an average of the values in this vicinity and use that instead of the actual value. And so that's what we are going to do with the different types. And so let's talk about the different types. Centered moving average being the first one we come to on the operator. And in a centered moving average, the new value at each time is an average of itself plus a certain amount of values before that time and a certain amount of values after that time. It's called centered moving average because the new value is put at the center of the averaged window. Now, a centered moving average has to have an odd number of values because the value itself is included, and you need the same number of values before it and after it. So that implies you have to have an odd number greater than 2. You can use 3. Probably wouldn't get a whole lot of great smoothing, but you can use that. It's engineering judgment or technical judgment to decide how many values to include in the smooth. Now, there is a variation of centered moving average called Olympic smoothing. And the name Olympic smoothing is taken from the practice of Olympic scoring, where there are several judges and their scores are averaged, but only after they throw out the high value, the high score, and the low score. The remaining scores are averaged. So that's what we do with Olympic smoothing. It is the same thing as centered moving average, except within the window, you throw out the highest value and the lowest value, you average the remaining values, and that becomes the new value. So it is a variation of centered moving average. Forward moving average. It doesn't use values on either side of the new value. It only uses values prior to the new value. So the new value at a given time is the average of itself and some number of values preceding that value. And that is assigned at the new value at the time in question. Now, why would you want to use a centered moving average versus a forward moving average? The traditional answer to that was you would want to use a forward moving average when you needed the average to come up to the current time. And the reason is, if you're using a centered moving average or its variation, Olympic smoothing, you can't average up until current time because you don't have times after that time to include in the average. So by necessity, the average stops at half of the window size away from current. Forward moving average doesn't have that downfall since it only averages values prior to the current time or prior to the time at hand. It can average right up until the current time. But there's a downfall. Using forward moving average, the average doesn't track the data, it lags the data. And so you can average right up until the current time, but the average of the current time only includes, the last so many values. And so the center of that average is in the past. It's not actually at the current time. So both have their uses, both have their drawbacks. One way to lessen the drawback of using a centered moving average or Olympic is to check in the operation on the operator specific area. Not use only valid values. Hopefully you'd want to do that because you don't want to include bad values in your averages. Hopefully, but to check use reduced number of values. And what that does is it allows the centered moving average to use fewer than the number of values you specified. So when it's at the beginning of the time series, if it doesn't have the prior values to use, it's okay. It will just use the values it has. It will decrease the number of values it averages over to be able to average up until the edge. And that same thing is true of if you're averaging up until the current time. You don't have future values to include in the average, but it will just average over a smaller number of values in that circumstance. And so you kind of don't have the real advantage of forward moving average anymore, except depending on how badly you want your data to be smoothed, because the smoothing drops off at the edges of the centered moving average and Olympic smoothing because it is averaging over fewer number of values. So there's a place for your engineering judgment, your technical judgment to come in as to what type of smoothing you would want. And, if you're using historical data and you don't worry about anything about the current time, then, centered moving average to me seems better simply because it tracks the actual data without a lag. But the choice is up to you. That is the smoothing tab. That is all that is on the smoothing tab. I will say, if you notice, in the operator specific area there, we can say single data set, so the selected data set as we talked about. But if you start the math functions dialog with several data sets selected, the smoothing tab will let you smooth all of the data sets that you started with at once. You don't have to do them one at a time. So it does have an option for multiple selected data sets below, and you can select which data sets you want to smooth. You can select all of them and smooth them all in one fell swoop. Okay, let's move on to statistics. You may or may not remember that in the previous session I said that the operator in the statistics tab was not called operator, it was called type. And here we see that. And we have the basic type selected, and with the basic type, you don't have to do anything. You just select it, and there it is. It gives you all of the statistics, all of the basic statistics for the selected data set. The number of values, number of valid values, the last valid date and time, the min, max, the standard deviation, all of these things, the accumulated amount. You even get the skew if you want to. Well, even if you don't want it, it's there. And so all this information is provided just by selecting the statistics tab with the basic operator or the basic type, and there you have all the information about your data set. I should have clicked that because I was talking about basic. My bad. So we can also do single linear regression. You may remember in a previous session back on the hydrologic tab, I said we could do multiple linear regression, and there we can compute and apply the regression constants. I mentioned at that time that if you wanted single linear regression, you had to come to the statistics tab, and here's where you come. You come to the statistics tab under linear regression, and you can compute regression constant. The next operator is my favorite. The next type is a cyclic analysis. And a cyclic analysis is used for a period of record analysis, or at least a long running analysis. And it breaks your data into bins and gives you the statistics for each bin. So if you have hourly data, you will get 24 one-hour bins, and so you'll get statistics about each hour in the day. If you have daily data, it'll break it up into 365 one-day bins, and you'll get statistics for each day of the year. If you have 1 month data, it will break it up into 12 one-month bins, and you'll get statistics for each month of the year. And this works, the longer the period of data you give it, the better the statistical analysis will be. That's why it says mostly for period of record. And when you compute this, it gives you the min, the max, plus the percentiles at 5, 10, 25, 50, 75, 90, and 95, and the standard deviation. And the fun thing it does is it throws them all out into the year 3000, because it has to put them in a time, but it doesn't want to put them in a time that you might believe is real. And so here is a statistical analysis this is 1 day data. So we have 365 1-day bins. You see all the statistics calculated there. And you see the year 3000, which I love because it makes us feel like we're in the future. So there you have the cyclic analysis. Excuse me. Okay. Before we finish up with what is left on the statistical tab, I want to throw out a caveat that HEC-DSSVue is not HEC's statistical software of choice. It provides simplified analysis. It does not provide the type of analysis that you would need to perform a planning study or for anything sophisticated. You wouldn't want to, impound a reservoir based on the data that you get here. Let me just say that we have SSP, the statistical software package, that provides all of that sophistication for you. So if you need actual sophisticated statistics, please don't use HEC-DSSVue, but use HEC-SSP instead. Now, having made my caveats, I'll make it on each of the other types as well. So I keep wanting to say operators. But one of the statistical types is a duration analysis, which computes a frequency curve. So if you want to see a percent exceedance of a flow, say, and you want just a simplified version of that, then do that. Again, it does not perform a volume duration frequency analysis. We have software that does that. This is not that software. However, it can give you a quick look and a feel for exceedance probabilities of different parameters. This one's showing flow, of course, and so if you need that to get a quick feel for something, it's there. And if you're using this tool and that's all you need, then it's there at your service. The same thing is true on the frequency plot. It does compute and display a frequency plot, if I can say that, for peak annual data, but it doesn't perform the detailed frequency analysis. It doesn't allow you to have control of all the parameters that you would need for a sophisticated statistical analysis. Again, we have SSP, so please use it for that. However, if you have data and you want to get an idea of the frequency, or excuse me, of the probability, then give it the data, hit frequency plot, and it will do a quick analysis for you. That is it for the tabs. That is it for the operators. We've covered 6 category tabs and 60 plus operators in a short amount of time. So let's wrap this up. We started off saying we were going to become familiar with the capabilities of this software to perform time series data operations that included these: generation of new time series, modification of existing time series, and analysis of existing time series. And we did that. We saw that the math functions dialog, all the operators generate, not all of them, most of them generate new time series. We can then save those time series with the name that's given, which is a modification of the existing name. We can modify that name and save it back to the original time series if that's what we want. I don't recommend doing that. I like to keep all the raw data, but you can smooth the time series and save it back to where it came from if you don't want a proliferation of path names in your DSS file. So you can do the generation, you can do the modification of existing. We also saw most dramatically just in the statistics tab how you can do analyses of existing time series. Now, there were other analyses throughout the tabs that we saw. We saw in the time functions where you could perform period-based analyses, period-based statistics on, you get the min and max within a period, or the number of values, or those types of things. So it's not just the statistics tab that allows this, or that provides this, but primarily the statistics tab allows you to perform the analysis of the existing time series. We said that we were going to look at this stuff to become familiar with these in the following categories. And the categories are the tabs that we covered, and we covered them in this order. In session 3, we looked at the arithmetic and the general tabs and the operators in those categories. In session 4, we looked at the time functions and the hydrologic tabs and the operators in those categories. And finally, in this last session, session 5, we looked at the smoothing and statistics tabs and the operators, and or if you want to call them types, in those categories and the operations and analyses that they perform. Hopefully we have met all of our objectives. Hopefully, if you're not yet an expert in using the math functions of HEC-DSSVue, you at least have the background and the basis to start using it to become that expert.